In today's video, we'll guide you through how to post-process your scan data to get it ready for import into your CAD software. The first step is to reposition the scan part in the coordinate system. This is crucial for aligning the geometry with the design intent and ensuring downstream compatibility with the CAD software. In Peel.CAD Pro, we start by creating reference entities. Planes, extracted from flat surfaces. Axes, derived from cylindrical features, and points, selected from key locations on the mesh. These entities help us define a local coordinate system. Once defined, we use the reposition tool to move the part to the origin and align it with the global axis. This step ensures that all subsequent features are built on a stable and logical foundation. After repositioning the part in the coordinate system, the next step is to extract a cross-section to begin building the parametric geometry. In Peel.CAD Pro, we use the cross-section tool to slice through the mesh at a defined plane. This gives us a 2D profile of the part at that location. Once the cross-section is generated, we switch to the sketching environment. Here, we can manually trace the profile using standard sketch tools. Lines for straight edges, circles for round features, arcs, splines, and other primitives as needed. Peel.CAD Pro allows us to apply geometric constraints to ensure design intent. Parallel and perpendicular constraints, coincident and concentric relationships, equal length, horizontal, and vertical constraints. These constraints are essential for creating a robust and editable sketch that can be used to generate solid features later on. With the sketch fully defined and constrained, we're ready to create our first solid feature. In this case, we'll use the revolve tool to generate a solid body from the profile we sketched in the previous step. The revolve operation works by rotating the sketch around a selected axis, typically a center line or a reference axis, extracted from the mesh. This is ideal for parts with rotational symmetry, such as shafts, pulleys, or cylindrical housings. In Peel.CAD Pro, we select the sketch profile, define the axis of revolution, set the angle of rotation, usually 360 degrees for full solid, and confirm the operation to generate the solid body. The result is a clean parametric solid that can be further modified or used as a reference for additional features. This step marks the transition from mesh-based geometry to true CAD solids, enabling downstream operations like dimensioning, simulation, and manufacturing preparation. After creating the first solid using the revolve tool, we move on to adding additional features to complete the part geometry. Peel.CAD Pro provides a full set of parametric modeling tools that allow us to build up the part step by step. Depending on the design, we can use extrude, select a sketch or profile, define the extrusion direction and depth, and create protrusions or cutouts. Cut. Use sketches to remove material from the solid. It is ideal for slots and holes and internal cavities. Fillet and chamfer. Apply rounded or bevel edges to improve aesthetics or functionality. Useful for stress reduction and assembly fit. Shell. Hollow out the part to a defined wall thickness. It is common in plastic part design. Each feature is added in a history-based workflow, meaning you can go back and edit sketches or parameters at any time. This flexibility is key for iterative design and engineering validation. As we build the model, we continuously compare it to the original mesh to ensure dimensional accuracy and geometric fidelity. Once the solid model is complete, the next critical step is validation, ensuring that the CAD geometry accurately represents the original scan part. Peel.CAD Pro offers several tools to help with this. Deviation analysis compares the CAD model to the original mesh, displays a color map showing areas of deviation, and helps identify regions that are over or under modeled. This visual feedback is essential for confirming that reverse engineered parts meet the required tolerances. Dimensional checks measure key features directly on the CAD model. Cross-check with physical dimensions or technical drawings, and validate critical interfaces and mounting points. Iterative refinement If deviations exceed acceptable limits, we can go back and adjust sketches, features, or constraints. The parametric nature of Peel.CAD Pro makes this process efficient and traceable. Validation ensures that the final model is not only geometrically accurate, but also functionally reliable for downstream applications such as manufacturing, simulation, or quality control. With the reverse engineered model validated and refined, the next step is to export the CAD geometry for use in downstream applications. Peel.CAD Pro supports export to several industry-leading formats, including STEP. That is ideal for interoperability with most CAD platforms, and maintains solid geometry and parametric features. IGS. That is commonly used for surface models and legacy systems, and is useful for CAM and simulation workflows. DXF or DWG for 2D profiles and sketches, and is compatible with drafting and CNC software. To export, you need to navigate to the Export menu, choose the desired format, select the desired model or features, confirm, and save the file. The exported file can now be imported into CAD software like SolidWorks, Inventor, Fusion 360, or CATIA for further design, analysis, or manufacturing. This completes the reverse engineering workflow from scan to CAD using Peel 3 and Peel.CAD Pro.